Okay, so let me ask you this. Which portion of chemistry do you, it's not what you like best because science isn't for everybody, okay, and we get that. Uh, the reason we mention that is when you say science, that's a pretty vague term because science is biology, it's physics, it's chemistry. Any one of those, it's earth science. Okay? So then when you break down the physical sciences, that's a vague term as well because that means there is conceptual physics, there's applied physics, there's, let's say, theoretical physics, there's, did I say particle physics? Okay, there's analytical chemistry, there's organic chemistry, there's inorganic chemistry, there is probably theoretical chemistry as well. What might I be missing? Quantitative chemistry, qualitative chemistry. See where we're going with this? There's a lot of specificity if you want to name that. But for this course, just for the chemistry portion of physical science, if you had a preference, would you rather spend an entire semester on what we're doing now, the organic chemistry portion, or would you rather do the entire semester on the inorganic portion? The difference is, if you're talking about inorganic, that is the periodic table, acids, bases, chemical reactions. Organic, yes, there's reactions involved with that, but it's all organic compounds. So if someone asks you, well, what is organic chemistry? The very basic and most general definition you could give would be what? What does organic compounds deal with? Mainly what? Carbon and hydrogen. Those are your main two elements that we deal with organic compounds. Yes, there's oxygen, there's nitrogen, there's phosphorus as well, but and some sulfur. But for the most part, when we're dealing with the organic portion, you're just looking at this really small neighborhood, element 6, 7, 8, 15, 16, and the halogens then as well. Other than that, the rest of this you really don't deal with much with organic. Although this one you would, iron, when it comes to hemoglobin, why might that be? Does anyone think they know? What is hemoglobin? Does anyone want to take a guess? Exactly. Hemoglobin is blood. So how does oxygen make its way through the body then? Because the oxygen attaches to the iron atom, and that's how it's circulated. Okay. I believe this is where we left off with. And when it comes to naming these organic compounds, okay, if you did not know anything else, the OL is telling you what? That you're dealing with an alcohol. OIC, but we don't, IOC, sorry. Oh, I do have them backwards. Should be OIC. This suffix is telling you you're dealing with a what? With an acid. So how many different organic families have we talked about this chapter so far? Just think through your mind and try to come up with a number. How did you, yeah, okay. So, alkanes, alkenes, alkynes, then what? We said that already. Nope. Alcohols and acids. That's right. Okay. Now, one question on your paper, and for those of you who didn't know, you just do the right thing and you ask. propyl chloride or chloropropane. Okay? Is that a different category of organic chemistry, do you think? Is that a different family? Well, if it's called chloropropane, that would mean that you're dealing with which organic family? What's the suffix? Propane. Yeah, it's still an alkane, so it's not a different organic family. It's just a halogen derivative. And remember, what is another derivative besides chlorine, fluorine, bromine, and iodine? What's a different derivative that we've talked about? And you put them correctly down on that paper. We've only discussed two of them. We're making you think on this Monday morning. Two derivatives. Methyl and ethyl. And now you people are saying, I knew that. Maybe yes, maybe no. Okay. And this is where we left off with, correct? Okay. So, moving forward then, okay? So, substituting other elements, we've talked about this. One example is chlorine or other halogens. That's how we get propyl chloride or chloropropane, whichever you want to refer to. That's the example we just said. If you had questions on that, a lot of you said, how do we do this? We're more than happy to help you. Okay? So look at what this says. Other elements, as opposed to just hydrogen and oxygen, can be added to hydrocarbons. Okay? So what that means then is that's why if you just write those dashes on there, it's just understood that that is a hydrogen atom. If there's something other than that written, well then it's no longer hydrogen, but whatever it is that's substituting, whether it's a chlorine or an oxygen atom. So, now that we've been doing this for, is it 2 weeks now? Pretty close to 2 weeks. From now to where we started, have you leaped forward by, have you made strides by leaps and bounds, or is this still fairly difficult for you, do you think? Who still feels comfortable doing all of this content? Nobody? I see 1, 2. So no one wanted to be the first one, did they? Okay, try that again. Okay. For those of you who are struggling, what have we said? See those people with their hands up? Okay. No one is behind them saying, hands up, then they'd have both. Hands up, give me some free knowledge. They're robbing from you. Then it's okay. Hands up, show me how to do this. Well, as long as you're working together, because last chapter, balancing equations. How many of you did very well on the daily work? Okay. What was it like on the, so nobody did well on the daily work? Well, not, some of you had your hands up. I've got documentation that tells me otherwise. So what's it like on the evaluations then? Is it matching the daily work? For some people, probably yes. So let's not repeat that, okay? Because we're slowly getting to our last opportunity. Because I'm thinking after today, you take those last 2 days off, those are your semester exams, okay, then I would say there's 17 days of school left, I think. So that strikes 2 off for semester exams and probably 2 or 3 days for reviewing, okay? So that just leaves us somewhere around 11, 12, or 13 days to get through the rest of this, which we're going to be fine. It's not like this is going to be a race where we got to push it into try to get through this content at the very end. We're going at the pace that is hopefully comfortable for you. How many of you think this is about the right pace to be going? And I think it's fair to say that. I do. Okay, so moving along. How many of you have a gas stove as opposed to an electric one? Just think about that as you're writing this, okay? And maybe some of you don't know. Of course, when it comes to skunks, okay? How many of you have a dog that just did not learn their lesson and just would not leave that skunk alone? And you think, serves you right, because you weren't smart enough, and I wouldn't say weren't smart enough, but you'd like to think that they may have learned. Are your dogs fairly young that had happened with, or? Okay. Because one of the things that that when we talk about this in not just biology but also more so zoology, okay? Think of a venomous animal. There's a whole bunch of examples you could give. Now, not poisonous, that's different than venomous. Okay, so you're touring, is it Dinosaur Park in not Rapid City, but western South Dakota, okay? Yes, as we know, there's western diamondbacks or rattlesnakes that are quite common out there, okay? But does that animal, rattlesnake, does it want to strike as a defense mechanism against you? You're shaking your head. No, that is correct. Why not? Well, it's got venom. It certainly can defend itself. But does anyone know what happens? Does the venom run out? It does. Does that mean that they're out for the rest of their life? No, because they've got venom glands. So any type of gland means it's going to produce something. The venom gland produces the venom. So when it's out for a short amount of time. So when that happens, it takes a lot of energy to recycle and make that venom, okay? So has anyone been feeling under the weather lately? Okay? And when that happens, how much energy do you have when you're under the weather? Not a lot. Because for the same reason, what is it in our body that's a defense mechanism against bacteria and viruses? It's a specific type of cell. And it's a color too, not red blood cells, white blood cells. Do you think that our body keeps those white blood cells in stock and ready to use upon time when this sickness arrives? No. there's what's called an immune response, which means you have to make that. It takes a lot of energy for you to make those immune cells. And when that happens, that's why you feel so worn down, because the energy for your regular metabolism is now being put in to make these white blood cells as a defense mechanism. So for the same reason, it takes a lot of energy for these animals to produce that venom. So what is it that a snake will do, especially a rattlesnake? There's your clue to say, stay away. It's going to have that. How many of you, sometimes I think, not a baby rattler, or a baby rattle, but sometimes I think it would be a good idea that if everyone could have like the tail of a rattlesnake and it's on their pin or something. And when someone's getting too close to them or someone's, they just take it and start shaking it. Then what do you hear? I can't make the sound with my tongue. Something like that, yeah. Say, do that a little louder though. Shh. How's that? So what does that tell any other animal to do? You better stay away. Okay? So that might be the first sign. Okay? Well, how do you know that it's a diamondback snake? Because it's got diamond patterns on its back. Okay? And then finally, if you have not if you have not heeded the first warning, you've not heeded the second one, then it could be such a thing, there is no choice. They're going to try to defend themselves, so then they strike. Okay? With a skunk, on the other hand, okay, they have defense mechanisms just like other venomous animals. The first thing, well, how do you know you're looking at a skunk? Yeah, you've got a white stripe going down the middle of their back. Okay? So, if you encounter a skunk, guess is probably scared to death of you. Okay, you might not think that, but that's what's going through their mind. So, they're going to make it well known, flip up their tail. Now, the head, you're looking at them. You're not looking at the tail side. You're looking at them. Why would they arch their back and flip their tail up? Well, maybe look bigger, but you're certainly going to see a thick white stripe going down their back. You're going to say, are you sure you want to come closer? Okay? That's the first warning, just like that of the snake. The second one is, now there's no way you would know this, because you'd have to have a class in zoology or to know animal behaviors. The next one is they jump, they lean forward like this. Kind of like when, let's say, guys or gals basketball players. Who can I pick on? Okay. He's young Kelby. He's got the ball. He's in the corner behind the three-point line. Shoots it. Nails it. Doesn't even touch the rim. Goes right to the hoop. Okay? The other team turns it over. Now he's in the other corner. Hit him with a pass. It goes up. Doesn't even touch the rim. Right through. 6 points in no time. And then he hits another one. And then another one. So let's say, holy cow. He has hit 5 in a row. Okay? And then he shoots another one and it goes through. And then people say, wow, they do things like this. You ever seen that in athletic events? Say they bow down thinking, wow, they're really good. So think of something similar to that a skunk would do to say, hey, you don't want to get any closer. 1, you've seen my tail. 2, I'm going to make sure that you see this white stripe. And if you still haven't learned your lesson, they turn around and you don't want to be, I don't know how many feet, I'm sure it's probably quite a ways. So with that, with those 2 previous behaviors, just like the snake, does a skunk want to spray you? No, it doesn't. Or else, if it did, it would just turn around right away. But it takes a lot of energy to produce these compounds called mercaptans, okay, which results in something called a thiol. You know when someone has hit a skunk long before you see them on the side of the road. Or you know that one is close to your property long before you see them. Okay? So if that's the case, why would, whether it's XL Energy, because I think Sioux Valley, that's all electric, correct? I think it's XL Energy in Sioux Falls that is natural gas. So why does this mercaptan have to be put in to natural gas lines? Well, it's natural gas. Why doesn't you know that it's leaking? It's natural. Say that again. It doesn't have a smell. So when these companies put this in, it's very evident and it's unmistakable to know we've got a gas leak. Okay, so does anyone in here have a gas range, gas stove? Okay, if you've ever had to change that, okay, if you don't shut the valves off, you would know you have a gas leak. Has that ever happened? Was it very evident we've got a gas leak? You're nodding your head yes. Okay. So let's see here. We don't want to move on to petroleum yet. So we're not done yet. So as we move forward, okay, we've got some different exercises we could be working on here. Let's see here. Okay. So write these down. Don't write them. If you're not comfortable doing these, I would highly suggest you write them down. But I'm not going to walk around and say, you need to be doing this. Because it's kind of like the announcements that you heard before this class started with the bikes, correct? When you ride a bike to school, what would common sense probably tell you to do? Put it in the bike rack. Pretty simple, right? Okay? So if you don't understand this, I think it would be pretty simple to say, okay, perhaps we should be writing these down. I mean, just like we hope it's common sense, put the bike in the bike rack. Okay. So, I'll give you a little bit of time to go ahead and write them down, and then we will proceed forward. Okay, so as you're looking at these, okay, I see my batteries flashing. That's what it's getting low on power, so I don't want this to go out. that walking beans was one of my summer jobs, and it was okay, but it got to be a lot better when they got little radio transistors that you could actually listen to music while you're walking beans. I mean, just made the time pass just a little faster. So, your probably number one response is, that's stupid. Why would you walk up and down a bean field and pull weeds? Yep. Okay. So go ahead, and we got brown, what would you say, brown, blue, orange, green, then I don't know if this is a teal, whatever, and then whatever, red, pink, salmon, whatever. Okay, pick a color. Okay, so blue was the first one that we heard. Okay, so the first thing that you would do with this is find what? The what chain? The parent chain, which is also the longest continuous one, which is how many? It's 5, okay? So the prefix for 5 is what? P-E-N-T, okay? That means 5, okay? And if this was not on there, we know that this would be pentane. Okay, we can go a little further. If that was an E, that's telling us that's an alkane, but it's not an alkane. What is the organic family we were referring to? Yeah, it's an alcohol, so what is the suffix for an alcohol? OL. Okay? Now, we don't just have pentanol, because this would be pentanol. You could say 1-pentanol, but that's not the case. It's not on the first one. It's on which one? It's on the third one. 3-pentanol. And what that means, so if we reverse engineer this, okay, again, inside the box, what is that telling you? The organic family, or that it's an alcohol. That's right. And then this is telling you what? That's the number of carbons you have. So then this number must be referring to this, which is telling you an alcohol has what 2 elements in it? It's a hydroxy compound, which is hydrogen and oxygen. Okay? So the 3 is referring to this here. Okay. Organic family, parent chain, and since there's nothing written after that number, it's either telling you where a double bond is, where a triple bond is, or where that alcohol is located. Because typically, it would tell you where the other derivatives are, like that of ethyl or methyl. But there's none of those branching off of there. So this 3 then is referring to where that alcohol is. Left outside, are we okay? Left middle, middle, right middle, right outside. Okay, so this can then be erased. So would 3-pentanol have an isomer? In other words, what is this is the structural formula. What is the molecular formula for 3-pentanol? How many carbons are there? 5. How many hydrogens are there? 5, 9, 10, 11. I bet you there's 12. There's 12. Okay? And what's left? Okay? Now, sometimes you might see 5H11, maybe OH, but the top one makes more sense. Okay? So, what might an isomer of 3-pentanol be? How about we say 2-pentanol? Have we changed this? Was it the same structure? How? Yeah, so it's the same molecular formula, right? Is the structure the same? No, because it used to be on the third carbon, now it's on the what? No, it's on the second one. That's a different structure. Does this have another isomer? Yeah, how about pentanol? What we just said. Let's take this off and put them over there. Okay? Remember, what is the definition of an isomer? Same molecular formula, but different structure. Those are three different structures. Okay. Pick another color. Brown. Okay? So, you know, if we've done this before, just take out a piece of paper and you name these and I'll collect them. Sounds like a plan, don't it? No. So why do we say things like that? Just enlighten me. Why? Because it's coming over here, okay? So, right? So, tell me if I'm wrong. 1, 2, 3, 4 rows. You're not given colors like that. How many say it's funny? How many of you think it's annoying? So, they're all wrong? Is that a presumption? Enlighten us. Just say they're all wrong. No? Nothing? Okay. Believe it or not, some people, not that you find this interesting, but probably see some validity in it. All right? Value. That's what validity means in that context. Okay. So, parent chain. What is it? 4. What's the prefix for 4? Okay. So, now, is there anything branching off of those 4 carbons? Yeah, there's chlorines. Okay. So, we can call this butane, but it's not just plain butane. This would be butane. But what is branching off of those carbons? Chlorine groups. Where are they located? 2 and 3. Okay, so 2, 3. I didn't leave enough space. Make sure you do that. 2, 3 dash, but not just chlorobutane. What means 2 derivatives? Dichloral. Okay? Okay? So, this intuitive leap that we've made. Left outside, are we good? Left middle. Middle, are we good? Right middle. Right outside. Yes? Okay. And we can reverse engineer this, okay? It's an alkane family, okay? It's got 4 carbons to it. This says there's chlorine attached to it. This says that there's 2 of them, and this tells you where they're at, okay? So again, when we do this, the idea is to hopefully help you distinguish what these prefixes, suffixes, numbers, and terminology means with that. Okay. Okay, you said And let's say if we handed this in and you put an L there, no, I wouldn't count that wrong. We're not organic chemists in here. We're just trying to get on the way to giving you a nice foundation. Okay? And one way to look at that is some of you maybe look at this, oh man, look at that Roadster, that Tesla Roadster we could have, or a McLaren. I think it's, I saw this on the national news on Saturday morning. Is it maybe, I think we're done with this. We're not good. It's, is it maybe Mustang? They're trying to break the 300-mile-an-hour barrier. They're up to about 200 and 250, 270 maybe. Okay? And when you're going that speeds, just one, I think you'd agree, just one little twitch of the steering wheel could certainly produce havoc on where that car's going. So, but with that, pretty phenomenal things. I guess the point that we're getting at is if you have that nice Roadster or that McLaren, man, look at that car. Doesn't have a transmission in it, but look at that car. Is it, well, it's worth a lot of money, don't get me wrong, but it's not worth as much as it should be. Why? What do we say it's missing? Transmission. Can it go anywhere? Well, no, of course not. Okay? So we want to make sure we have a nice wide foundation so you can build the walls and the roofing on this. What good is a roof and walls if you don't have a good foundation on there? There's nothing. It's not going to stand test of time. Okay, so next color. Okay? What is this? Okay? So we have benzene. Okay? And then what is that derivative right there? Okay? And you've got methylbenzene. You don't have to give it any numbers because it needs to be on what when you think golf? The smallest number. If you want to write one methylbenzene, that's fine. The only way that would change is if you had seen or would see something like this. Okay, don't put that down. Okay, that's the only reason that would change is if you had two different derivatives on this compound. Okay, but otherwise you just call it methylbenzene. That's it. Can we erase this? Okay. Next. Okay. So, just looking at this, what can you tell me about propanoic acid? Okay, you're saying there's three carbons. Let's go ahead and put them in. Okay, so we've taken care of this. Now what can you take care of? You're exactly right. Where would they have to be placed? Okay, so you can put it on, just as long as it's on the first carbon. You want to go left or right? Okay, so say that again, what you said earlier. You need what and what? Okay, so there's our hydroxide and a double bonded oxygen. Okay, so what about the bonds between these three carbons now? Is it single or double or triple? Okay, it's all single. The reason we know that is because of this guy right here. All right. Now, we've accounted for this organic family because it's right here. We've accounted for these 3 carbons. There they are. Okay? What's the last thing that we would need to do? What is a methyl group? It's a derivative. What's the formula for a methyl group? CH3. Can we put them over here? No. We're going to put them here. You said CH3. You can write it like that if you want. It means the same thing as this. Whichever one you're more comfortable with. Okay, so we've accounted for our acid. There's our 3 carbons. We say that there's a methyl group. There it is on this second carbon. Okay, should you have done something like this, say, I don't know why that would happen, but now what would you have? You don't have propanoic acid anymore. You've got what? Butanoic acid, because now you've got 4 carbons on there. Okay? All right. So we'll put him back here where he belongs. Are we good with this one? Oh. Yep. And here. Yep. That's correct. Of course, we all knew that, right? Yeah. Unfortunately, we're getting close to running out of time, and I think that's probably good for today, unless we've got some objections. Okay, so we will discuss those last 2 tomorrow. Okay, catch up to you next time.